Hello there, Mr. Sutton here with the AB Calculus Chapter 3 Quiz 4 Review Solutions on Derivatives of Transcendental Functions. For this problem, we're going to use the chain rule since I have a function inside another function. So we'll start with the outer function, which is something to the 13th power. Derivative of that is going to be 13 times something to the 12th, so 13 times all this stuff without any change to the 12th power. Then we're going to multiply by the derivative of the inner function, or functions. In this case, there's just one function, and it's a polynomial. So going left to right, we have derivative of 5x to the 6th, which is 30x to the 5th. So I'm going to multiply this in a parentheses right next to the original here. And then we have 8x squared becoming 16x. And then we're done. For this function, I'm going to try to use the chain rule to find the derivative. So my outermost function is something to the 12th. Derivative of that is going to be 12 times something. In this case, all the stuff in here with no change. All of that raised to the 11th power. Next, I'm going to work my way in and take the derivative of the next function and multiply that out here. So derivative of 1 is just 0. So we move on to this sine cubed of x to the 5th. Now for this expression, the outer function in here is the third power. We're taking sine of x to the 5th and raising all of that to the third. So I've got derivative of something to the third, which is 3 times something squared. So our next chain then, our next link is going to be 3 times sine squared of x to the 5th. All right, next I have to take the derivative of sine itself, because I was just taking the derivative of an exponential, a power term before. Now I'm doing a trig function. So derivative of sine of something is going to be cosine of something, so cosine of x to the 5th. Finally, I need the derivative of x to the 5th itself. That's going to be 5x to the 4th. Taking the derivative on this one, I'm going to start by rewriting this first term. So what I've really gotten here, it's kind of confusing, but this is cotan of x, and I'm raising that to the second power, and then taking the 7th root. So I can condense all that into a single exponent. I can write this as cotan of x to the 2 over 7th power. And now I can just use my power rule on this term. It's a chain rule in general, though, so I'm going to have to be careful here. So taking the derivative, I've got 2/7 times something to the, let's see, what's 2/7 minus 1? That's going to be negative 5/7. So 2/7 cotan of x to the negative 5/7. Now I have to take the derivative of cotan of x. That's negative cosecant squared of x, and we're multiplying by that. Over here now, we've got a power rule. This is going to be minus 3 pi x squared. On this problem, I want the derivative of square root of tan of 2x. So this is going to be a chain rule. The outer function is the 1/2 power. So I have, for the first derivative out there, I've got 1/2 times something, tan of 2x in other words, all of that raised to the negative 1/2. So that takes care of the outer derivative. Now I have to take the derivative of tan. So we have tan of something. Derivative of that is secant squared of something, so secant squared of 2x. And then finally, I need the derivative of the innermost function 2x, which is just 2. On this problem, and in general, when you're trying to take the derivative of a product that you can't simplify away, we're going to use the product rule. That's y prime equals u prime v plus uv prime. And remember, to help us with this, we use a box and ribbon to organize things, or we could anyway. So in the top left, I've got my first factor, 1 minus cosecant of x squared. In the top right, my other factor, 1 minus cotan of x cubed. Down below, I have the derivatives of these things. So derivative of negative cosecant of x squared. Well, derivative of negative cosecant of something is going to be cosecant of something, cotan of something. So this is cosecant of x squared, cotan of x squared, times the derivative of the inner function x squared, so times 2x. And then over here, I'm going to have, let's see here, this is derivative of negative cotan of something. That would be cosecant squared of something, so cosecant squared of x cubed. But again, I have to multiply by the derivative of the inner function, so we have a 3x squared along for the ride as well. All right, putting this back together, I'm going to use the ribbon to organize the order of multiplication and addition. So I've got this stuff in the lower left here, times the stuff in the upper right, so parentheses 1 minus cotan of x cubed. Now I'm going to be adding the stuff in the upper left. So that's 1 minus cosecant of x squared being added there, times, now the stuff in the lower right, cosecant squared of x cubed times 3x squared. On this problem, and in general when you're taking the derivative of a quotient, it's a good idea to use the quotient rule if you can't simplify. So that's going to be u prime v minus uv prime all over v squared. And just like the product rule, we use the box and ribbon to help organize things. So we've got the numerator in the upper left. That's 1 plus x to the fourth all raised to the 2/3. And in the upper right, we have the denominator, secant of x to the sixths. And then down below here, we have the derivative of the numerator. So using a chain rule and some power rule, that's going to be, let's see, we have something to the 2/3. So derivative of that is going to be 2/3 times something, x, 1 plus x to the fourth, to the negative 1/3. So that's the derivative of the outer function. Now we multiply that by the derivative of 1 plus x to the fourth, which is 4x cubed. Over here, we have secant of something. Derivative of that is going to be secant of something, tan of something. So secant of x to the sixth, tan of x to the sixth. Now we have to multiply by the derivative of x to the sixth. That's 6x to the fifth. And now we're going to use the box and ribbon, the ribbon part of the box and ribbon, to put it all back together. Starting in the lower left, we've got all this stuff here. That's our u prime. Multiplied by v, that's the upper right. Minus this stuff up here in the upper left, times all this secant of x to the sixth stuff down here. So that's all going to be divided by v squared, which in this case means secant of x to the sixth squared. To take the derivative of this equation, we're going to need to use implicit differentiation because we cannot isolate y, so it's imp diff to the rescue. This first expression is going to require the product rule, so we have a factor of x and y squared. Derivatives of those are going to be 1 and 2y times dy over dx, or y prime. Y is treated as an inner function, so with this whole imp diff thing, we have to always multiply by dy over dx because that's the derivative of y, the derivative of the inner function, whenever you differentiate something with y. All right, so multiplying that out with the ribbon, we have y squared plus, this will be, let's see, 2xy dy over dx. Moving on to the next term, negative x, that becomes a negative 1. 2y to the negative fourth, that's going to be minus 8y to the negative fifth, times dy over dx, because again, you just differentiated something with a y. And then that's going to equal the derivative of 2, which is 0. So we're going to keep the dy over dx stuff on the left. Everything else is moving to the right. So we've got 2xy dy over dx staying put, along with negative 8y to the negative fifth dy over dx. Moving over to the right side, we're going to subtract y squared to get that over there, and we're going to add 1. So there we are. Now let me factor out a dy over dx, leaving me with 2xy and negative 8y to the negative fifth. Dividing by this parentheses here, there's our derivative. And it looks like that's it. For this problem, we're going to be using the chain rule. So I have cosecant of something as the outer rule. That becomes negative cosecant of e to the x, cotan of e to the x. Now we have to multiply by the derivative of e to the x. In general, an exponential term, the derivative is going to be the base to the power times the ln of the base. But since the ln of e is just 1, its derivative ends up being e to the x also itself. So we're just going to multiply then by e to the x. And that is done. On this problem, I'm going to take the derivative of this expression. Since I have two things being multiplied and I can't really combine them, I'm going to try using the product rule here. So there's my product rule, u prime v plus uv prime. Let me set up the box and ribbon to help organize things. I have factors of 3 to the x and 1 plus 2 secant of x to the fourth, or 4x rather. Derivatives of these, 3 to the x is just going to be 3 to the x ln of 3. In general, you basically repeat the exponential term and then multiply by the ln of the base. Over here, this is going to be, let's see, 2 tan squared of 4x times a tail of 4, because the derivative of 4x there. Multiplying all that out, we end up with 3 to the x ln of 3 times all this stuff up here in the upper right in the parentheses, plus 3 to the x times all this stuff down here in the lower right, and I'll put that in a parentheses too, just to keep it all together. On this problem, I'm going to use the quotient rule because I'm taking the derivative of a quotient. So u prime v minus uv prime over v squared. Box and ribbon time. I've got my numerator, cosine of x squared. That's going to require a chain rule. Denominator is e to the x. That's going to be significantly easier to deal with. Derivative of the numerator, we have cosine of something. Derivative of that is negative sine of something, negative sine of x squared, times 2x, the derivative of x squared. E to the x is its own derivative. Putting things back in here now, I've got the stuff in the lower left times e to the x minus cosine of x squared times e to the x, all divided by v squared, which is e to the x squared. On this one, we're trying to take the derivative of this expression. So we are going to use the chain rule on this one, and we need to know about logarithms for the outer rule here. We have the ln of something. Well, derivative of that is going to be 1 over the something. So in this case, 1 over secant of 3x. Now we multiply by the derivative of secant of something. So derivative of that's going to be secant of something tan of something. So secant of 3x tan of 3x. Finally, we multiply by the derivative of the innermost function, which is just derivative of 3x is 3. For this problem, we're going to use the chain rule to take the derivative. So derivative of ln of something is 1 over the something, so 1 over sine of cotan of x. Next, we multiply by the derivative of sine. So sine of something becomes cosine of something, cosine of cotan of x. Finally, multiply by the derivative of cotan, which is negative cosecant squared of x. On this problem, we're going to need the quotient rule and a whole bunch of other rules. So that's u prime v minus uv prime over v squared. Setting that up in the box and ribbon, I've got my numerator, log base 2 of x squared. Denominator, 5 to the 4x squared plus 1. To take the derivative of log now, which is what I'm going to put in this box down below, I need to do 1 over the input times the ln of the base. So this is going to be 1 over x squared times ln of 2 times, now I have to actually take the derivative of x squared, which is 2x. Next, over here, taking derivative of 5 to the something. Well, that's going to be 5 to the something times the ln of 5. So 5 to all that stuff again, times ln of 5. And now the derivative of the something, derivative of 4x squared plus 1, that's going to be 8x. All right, so at this point, we're going to put it back together using the ribbon. I've got the stuff in the lower left, and also that's getting multiplied by the stuff in the upper right, minus I've got this log base 2 of x squared times this 5 to the 4x squared plus 1 ln of 5, 8x stuff down there. And then finally, I'm dividing by v squared. That's this upper right term squared. On this problem, to take the derivative, since I have a variable in the base and the exponent, and I can't simplify it away, I'm going to have to use logarithmic differentiation. So I'm going to start by taking the ln of both sides. On the left, I have ln of y. On the right, I'm going to pop out that tan of x, and I'm going to be left with an ln of x. That's what caused me to use my pop-out rule. Next, I take the implicit derivative. So on the left, this is 1 over y times dy over dx. On the right, we have a product rule with tan of x and ln of x, and derivatives of secant squared of x and 1 over x. So using the ribbon to multiply that out, we have secant squared of x times ln of x, plus, I guess you could write tan of x over x. Now to get dy over dx by itself, I have to multiply both sides by y. So I have y times parentheses all this stuff. And then y is just none other than x to the tan of x, so we could plug that one back in. To take the derivative of this expression, I'm going to need to use logarithmic differentiation because I have a variable in both the base and the exponent. So I'm going to log both sides here. I've got ln of y on the left. On the right, I've got x squared times ln of x plus 1. So just using the pop-out rule to pop out this x squared as a coefficient in front of the log. Now I use impdiff to get going a little bit further on this one. So derivative of ln of y, that would be 1 over y times dy over dx. On the right side, I have a product rule. So I have x squared and ln of x plus 1. Derivatives are going to be 2x. And let's see here, this is going to be 1 over x plus 1 for that derivative. times the derivative of x plus 1, but that's just 1, so we don't have to write anything else for that. Using the ribbon to multiply it out, I have 2x ln of x plus 1 for my first term on the other side of that equal sign, plus, well, I guess I could write this as x squared over x plus 1 if I multiply these together. Now we have to isolate dy over dx, so we can do that by multiplying both sides by y. So I've just got y times all the stuff that was already there in a parentheses. And if you needed to get this in terms of just x, you could substitute this x plus 1 to the x squared back in for y down here, and then call it a day. To take the derivative on this one, I'm going to use the chain rule. So I've got arc cosine of something. That's going to be negative 1 over the square root of 1 minus something squared, so 1 minus x cubed squared. And then I have to multiply by the derivative of the inner function. So the inner function is just 8x cubed. That derivative is going to be 24x squared. To take the derivative of this function, I'm going to go ahead and use the chain rule. So on the outside, we have arc cotan. Derivative of that is going to be, let's see, we have arc cotan of something, so derivative is going to be negative 1 over something squared plus 1. There we go, because normally it's negative 1 over x squared plus 1. But now we have an e to the sine of x in there. Next, I multiply by the derivative of this next function in. So we have e to the something here. Derivative of that is also e to the something, e to the sine of x in this case. Finally, derivative of sine of x is going to be cosine of x. So we'll multiply by that as well. And this is it. No need to simplify.